Hi guys, we'll be starting with one more very important discussion, one very interesting topic. Most of the students are always fond of this topic. That is nothing but ballistics, forensic ballistics, right? So let's start with ballistics. Ballistics is basically the science that deals with the movement of the projectile, the motion of projectile. What is a projectile? Projectile is a firearm or the lead shot that is coming out of a firearm, right? So we study the motion of projectile, that is called ballistics. But what is forensic ballistics? Forensic ballistics is something that deals with the investigation of firearm, the ammunition and the wounds that is produced by the projectile, right? So basically you're applying ballistics in the medicine, right? You're applying the principles of ballistics in the investigation of firearm, the ammunition and the wounds that are produced by this projectile. So all these things are forensic ballistics, right? See, there was a person called Calvin Goddard. Calvin Goddard was considered as the father of forensic ballistics. Remember Calvin Goddard, for his contribution towards the field of forensic ballistics, so he was regarded as the father of forensic ballistics, Calvin Goddard. Fine. Now let us see the ballistics in detail to start with. See, you can see this is called the fire lance. You can say this is actually the ancestor of all the firearms, right? See, this was first used by Chinese people in 10th to 12th century, wherein they had one long bamboo stick. At the end of the bamboo stick, they had this gunpowder. They used to ignite it and it is used to show fire, right? So this was the ancestor of all the firearms that we have right now. Now we have a lot of types of firearms. So we have a lot of advancements, a lot of refinements of all the firearms that we have. But for all the firearms that we have right now, right, this is the forefather, this is the ancestor. We call it as fire lance, right? This is the first firearm that was used by people in China, right, in 10th to 12th century. That's not MCQ, this is for general knowledge, right? Let's start with the ballistics. You can see a firearm, right? The bullet, the projectile comes out of a firearm and the bullet hits the target. It's a victim, right? If you study the structure of firearm, that is called proximal ballistics, right? It's otherwise called as internal ballistics, the movement of the projectile within the firearm. The movement of the projectile within the firearm, that is called internal ballistics, right? Proximal, internal, both are synonymously used, right? If the bullet has come out, it is traveling through the air. The study of movement of the projectile, the study of motion of the projectile, that is called intermediate ballistics, also called as external ballistics, right? After some time, the bullet hits the target, right? The study of effects of the bullet in the target, that is called terminal ballistics. The study of wound produced by this projectile, that is also called as wound ballistics, right? So we have proximal, we have intermediate, we have terminal. What is proximal? Inside the firearm, right? Intermediate, it has come out, it is in the air. When it is hitting the target, you call it as terminal ballistics, otherwise called as wound ballistics. Now you see the velocity with which the projectile is leaving the firearm. The velocity with which the bullet is leaving, for discussion purpose, let us keep bullet for projectile, right? The velocity with which the bullet is leaving the firearm, that is called muzzle velocity, right? This end of the firearm, that's called muzzle, and we'll be discussing that in detail, right? The velocity with which the projectile is moving, the bullet is coming out of the gun, you call it as muzzle velocity. The velocity with which it is hitting the target, that is called impact velocity, right? The velocity at the muzzle end, we call it as muzzle velocity. The velocity at the impact site, you call it as impact velocity. Just do get exposed with these terminologies. Now, see, now again, you have lot of types of firearm that we have in the world. You have n number of firearms in the world, but still, all these firearms will have certain basic parts, right? All these firearms will be having certain basic parts, right? So we are talking about proximal ballistics. We are going to talk about the structure of firearm, what are the things that are present in the firearm, right? First, we'll finish off proximal ballistics. For the proximal ballistics to begin with, I told you there are basic parts in a firearm. What are the basic parts in a firearm? There are three basic parts in a firearm. Number one, that is called breech. Number two, that is called barrel. Number three, that is called stock, butt plate or handle, right? So you can see these are three important parts of a firearm. What is that breech? See, barrel is something. This is called barrel. right? This part of the gun, this is called barrel, right? And this part of the gun, this is called breech. And the third part, this is called stock or the handle that is meant for the support. Okay, so you have stock, you have breech, and you also have a long metal tube that is barrel. We'll be discussing everything in detail, right? And just now I told you we have three parts. I repeat, you have something called stock, that is for handle. Then you have something called breech, right? Then you have a long metal tube that is called barrel. We'll be discussing on that. I told you the three parts of a gun, right? I told you breech, I've told you barrel, I also told you there is stock. Let us assume we are taking a section of this firearm. When we take a section of this firearm, we get something like this, right? You can see we have a section of barrel, we also have a section of breech, both are there. Now you see, let us say barrel, right? The barrel consists of two parts. You can see that it consists of what is called as chamber. See, this is chamber, right? It has got a chamber. In front of the chamber, you have a long metal tube. This long metal tube, right? This long metal tube ends, right? The end of the metal tube. This end of the metal tube is called muzzle end. The outer end of the metal tube, that is called muzzle end, right? Or you can say outer end of the barrel is called muzzle end. You can see the hole, right? You can see the tube. You can see the tube, that hollow tube is there. The internal diameter of the tube. The internal diameter of the tube, that is called bore. That's called bore, right? The internal diameter of the tube, that's called bore. Now you have a barrel. The chamber is connected to the barrel. The chamber is connected to the barrel by means of a constriction. You call it as a taper. It's tapering down, getting connected to the barrel. Fine. Now what happens is you have a chamber. The chamber, this part of the chamber is called breech plate, because that is in close relationship with the breech part. That's why it's called breech plate. We have a plate and that is in close relationship with breech. That's why it's called breech plate, right? Very simple. And inside the breech plate, you see the center of the breech plate will be having a small gap. There is a small gap in the breech plate. Fine. Now this is about barrel. Now coming to this breech. The breech mechanism consists of what is called as trigger. It starts with trigger. You can see this is trigger. The trigger, by means of a spring, it is attached to a vertical pin. This is called hammer, right? This is called hammer. And the hammer is attached to another horizontal pin. This pin is called firing pin, which is also called as percussion pin, right? So the mechanism is in such a way that if at all you pull a trigger, by means of the spring mechanism, hammer will go upward and the firing pin will move forward. Right? I repeat, you pull the trigger by means of a spring mechanism, hammer will go up and the firing pin will move forward. Where does the firing pin leave? This firing pin, you can see the tip of the firing pin, it passes through the hole in the breech plate. You can see there is a hole in the breech plate, right? Through this hole in the breech plate, this firing, you pull the trigger, the firing pin enters into the breech plate, right? That is entering into the chamber. Inside the chamber, we have a projectile. Right? Let us say, assume that this is a bullet. Assuming that this is a bullet, we are keeping the bullet inside the chamber. So when you pull the trigger, the firing pin comes forward, it hits the backside of the bullet and the bullet is going to come out. Right? The bullet is going to come out. This is the simplified version of the breech. And do remember, this is the simplified version and you have improvised version of firearm. You have modern firearms. All these firearms will be having this basic mechanism towards it. Right? So do remember, this is the basic mechanism. Now we'll be discussing about the different classification. Right? What are the classifications we have got? See, the firearms, I told you we have n number of firearms. Right? And you can classify the firearms under a lot of categories. Right? You can classify the firearms based on the number of barrels. Right? You can have only single barrel. Right? You can have double barrel, either in the side or on the top. You can have triple barrel, you can have single barrel, you can have double barrel, you can have triple barrel, you can have multi-barrel. Depending on the number of barrels, you can say where the single, double, triple or multi. You can see this is single barrel. Where you have only one barrel, you can see double barrel side to side, and you have triple barrel. And if you have multiple, that is called multi-barrel gun, right? Number of barrels. The next classification is based on how you load it. Let us say you have a gun, right? You have a gun, you can load either from the front of the gun or from the middle of the gun. When you load from the front of the gun, you turn, you load it in the front, we call it as muzzle loading. I told you this end of the gun, outer end of the gun, that's called muzzle, right? So when you load it from the muzzle, you call it as muzzle loading. You break the gun like this, right? You break the gun like this, you add the cartridge through this, you call it as breech loading. You know very well this is called breech part. You load it through the breech, that is called breech loading. So either it can be muzzle loading or it can be breech loading. In olden days, most of the guns were muzzle loading. Nowadays, muzzle loading guns will be very, very complex to deal with, right? So now what most of the guns, it's converted into breech loading, right? So you have muzzle loading, you have breech loading. This is breech loading. If you load it from the front, you call it as muzzle loading. Fine. Now the third classification is based on whether it is single or repetitive. What is that single? You fire a gun, that bullet has come out, right? You need to break the breech, you need to remove the empty case, and then you need to load the new cartridge again. Then again you can fire. Every time when you have to load it and unload it, you call it a single. Right? Repetitive is something where you don't have to load every time. You don't have to load every time. See, this one is single. Right? Every time you need to break it, you need to remove the empty case and you need to load a new cartridge. Right? Emptying the old cartridge, used cartridge, and loading the fresh cartridge, loading the new cartridge. Right? Every time you do it, that is single. Repetitive is something like where multiple bullets can be fired. You don't have to unload every time. You see what this is a kind of repetitive gun wherein you must have seen in many movies very commonly. This is a revolver. Why it is called revolver? It has got a metallic cylinder. It has got multiple holes in it, in which multiple chambers, and we need to call it a chamber. Right? So it has got a cylinder which has got multiple chambers in it. You can load multiple bullets in it. In most of the movies you must have seen revolver having 6 bullets, right? So you can see this is a cylinder which revolves every time when you pull the trigger. Right? You pull the trigger. When you pull the trigger, bullet is fired. The cylinder is automatically revolves and the new cartridge will come to the place of trigger. Right? The new cartridge will come to the place so that next time when you pull the trigger, another new bullet will be fired. Likewise, this cylinder will keep on moving. You don't have to remove the empty case every time. When all the bullets in the chambers are fired, then you can open, you can remove all the empty case, you can load new bullets into it. That is called revolver. The next type is called pistol. This is another repetitive type wherein you can see this is the pistol wherein you have a magazine in the base. You have magazine in the base where you can see multiple bullets are loaded in the magazine. And you will have spring mechanism over here that will keep the bullets tightly in the place, right? You pull the trigger, bullet comes out. Automatically what happens, empty case will be ejected and the new bullet from the magazine will be loaded into it by means of a spring mechanism. This is repetitive type, that is pistol, right? Then we have 2 more types. One is semi-automatic guns. Another one is automatic guns, just like your AK-47. What is semi-automatic? Semi-automatic, see, whatever I was telling you so far, you must have understood that what are the different mechanisms involved in this firing. When you pull the trigger, bullet is fired, step 1. After that, empty case has to be ejected, unloading, step 2. After that, what happens? New case has to be ejected, step 3. Okay, firing, unloading, loading. Firing, unloading, loading. So you have 3 important steps. With this semi-automatic gun, you pull the trigger, it is automatically fired, automatically empty case is ejected out, new case is loaded into it and it stops there. Right? You need to pull the trigger again so that another bullet will come, empty case is ejected, new case is loaded. That's why it is called semi-automatic, automatically ejected and loading. Right? There is something else called automatic. This is automatic, just like your AK-47. What happens is you pull the trigger. When you pull the trigger, it is firing the bullet, emptying the used cartridge, unloading happens, and loading of new cartridge happens. Again, it is fired. Right? It is firing, unloading, loading, firing, unloading, loading. This cycle will keep on going until you release the pressure. Right? Until you release the trigger. Right? Once you pull the trigger, it keeps on firing until all the bullets is fired off. Until all the bullets that you have got, it is completely emptied. Fine. Semi-automatic, automatic. Semi-automatic means for every bullet to come out, you need to pull the trigger once. But automatic, you just have to pull the trigger once. That is enough. All the bullets will be fired until you release the trigger. Fine. So this is called automatic gun. So these are all the different classifications that we have got depending on whether it is single action or repetitive action. There is one more type of classification that is called action. How you remove the empty case out. right? That is called action. We have three types of action. One is called lever action. You can see here, this is called lever action. You have a gun like this. You can see you have a gun like this. Once you pull the trigger, bullet comes out. You need to open this lever down so that the empty case is ejected out and the new case will be loaded. This is called lever action, right? Every time you fire, you open downwards, it will be ejected and new case will be loaded. That is lever action. There is something else called bolt action. You can see this is bolt action. Bolt action guns you can see in a lot of movies. You could have seen in a lot of movies, right? You can see this is called bolt. What happens? Let us say this is the gun. I have a gun like this and I have a bolt. This is bolt. I pull the trigger, bullet has come out, right? Bullet has reached you. Then I have a bolt. I will move the bolt so that it is opening the chamber. I will pull the bolt backwards so that it is emptying the used cartridge. Then I will push it forward. When I'm pushing it forward, new case will be loaded into the chamber. Then I close. When I move like this, it is closing the chamber. And I can pull the trigger, bullet will reach you, right? I will open, I will eject, I will load, and I'll close, pulling. So this is called bolt action that I am sure that you must have seen in a lot of movies, this kind of bolt action guns. So this is basically bolt action guns. Now we have one more type of gun that is called pump action. Third type, pump action, wherein, so this is the pump. Every time you pull the trigger, you need to pull the pump from below, right? When you pull it, what happens? Empty case is ejected, new case will be loaded. This is called pump action. Again, you must have seen in a lot of old movies, right? So this is pump action guns. This is pump action. So I've told you bolt action, I've told you lever action, I've also shown you what is pump action. So these are all the different actions that we have got, right? Fine. The third important one is based on the inner surface of the barrel. This is the last classification that we have got. And out of all this classification, for your examination purpose, this is so very important, right? Inner surface of the barrel. See, let us see, we have a gun, right? We have a firearm. We have a firearm. Fine. Now what we see is we are examining the inner surface of the barrel by an instrument that is called helixometer. We have what is called as helixometer. Imagine that it's like an endoscope, like you have a tip of camera will be at the tip so that you can pass through it, you can examine what is inside, right? So helixometer. Now, when you look at the inner surface of the barrel, one set of guns, you can see it has got, you can see I told you this is the breech end of the gun and the outer end is the muzzle end of the gun. You have in the inner surface of the barrel, what happens is you have lot of spiral groovings starting from the inner end, it goes up to the outer end. Suppose if this happens to be the barrel, the grooves goes spirally from the inner end to the outer end. It is not going like this. It has to go spiral grooves. If you are seeing that spiral groovings, do remember these spiral groovings are called as riflings. Right? So these spiral groovings are called as riflings. Fine. Any gun which is having a rifling, right? Any gun which is having a rifling pattern in the inner surface of the barrel, you can name the gun as rifle. Right? Rifling means rifle, as simple as that. What are the examples for this? You can tell a lot of examples for this. You can see that you have what is called as revolver, that is a form of rifle firearm. You have what is called as pistol, that is a form of rifle firearm, right? You have what is called as pistol, and you also have what is called as military rifle. So everything is there. See, revolver, the effective range, you can say it can reach up to 200 meters, whereas pistol 400 meters, whereas military rifle 1 to 3 kilometers it can reach. The range is 1 to 3 kilometers. Not so important for examination purpose. This is for general understanding. Right? Now see, I told you one type of gun which has got riflings in it, you called it as rifle. Another set of gun is there wherein you can see it has got a barrel and the barrel is completely smooth throughout the barrel. When you see the inner surface of the barrel, it has got completely smooth throughout the barrel. Then you can name that gun as smooth bored gun. right? We call this as smooth bore gun. It is so simple. When you have rifling, it is called rifle. When you have got a smooth surface, you call it a smooth bore gun. Right? Now you see, guys, here in a rifle, what is the projectile that we use? Projectile means what is coming out. What is the projectile that we use? Remember, here the projectile that we use is basically, here we are using what is called as bullet. Here we are using what is called as bullet in it, in a rifle. Right? This is very important basics, right? You can't make any mistake on that. When we say rifle, it has to be bullet. Right? It has to be bullet. For your examination purpose, you need to remember rifle means bullet, and bullet is made up of lead predominantly. Usually it is made up of lead. Not only that, in special bullets have got some other material also, copper, iron, powdered iron, everything is there. But for most of the bullets made up of lead. Most of the bullets are made up of lead. Similarly, in a smoothbore gun, what we are using here, we are using what is called as lead shots. Right? You can see it is called lead shots. Right? Or you can say lead pellets. As the name implies, made up of lead. Right? Lead shots, lead pellets. Again, mostly it is made up of lead. Now, since we are using lead shots in a smoothbore gun, this smoothbore gun can also be called as shotgun. Do remember, it is not SHORT, it is SHOT. Right? Don't say it is SHORT. That is not shotgun. Right? It will be a longer gun. Shotgun. Because we are using lead shots in it. Fine. Now, what happens is, I told you we are using bullet here in rifle. We are using lead shots in a smoothbore gun. Now, what is the purpose of riflings in a rifle? Why do you need riflings here? You are using bullet. Let us say this is the firearm. You have a rifle. It has got rifling in it. You pull the trigger. The bullet, let us assume this is the bullet. It traverses through the inner surface of the barrel, in which you have got spiral groovings. These spiral groovings going to spin the bullet. The spiral groovings will spin the bullet. Bullet will be spun. Right? It will be spinning. Why do you need spinning bullet? Why do you want the bullet to be spinning? You want the bullet to be spinning so that it is increasing. Remember, it is increasing the stability of the bullet. It is going to increase stability of the bullet. The bullet will not wobble, right? It will go straight. When it is going straight, automatically the range that it covers will increase. It will travel for a longer distance because it is stable. It goes straight, right? So the most important purpose of this is to increase the stability of the bullet. Right? When the bullet increases, when the stability of the bullet increases, the fatality will also increase because the precision, the accuracy will increase. Fine. Now talking about the shotgun, smoothbore gun. I told you we are using lead shots. Lead shots. Plural, right? We don't use one shot normally. We use a bunch of lead shots. Right? Let us assume that we are using a bunch of lead shots in it. Right? Now you pull the trigger, what happens? The bunch of lead shots, they come out. The bunch of lead shots, they come out, they don't go together. They don't go together, right? When you throw the lead shots, it is going to start spreading. Right? It's going to start spreading, and if it starts spreading like this, do remember it is called as dispersion. Remember, guys, this is called as dispersion. The lead shots are going to disperse. The lead shots are going to disperse. We call this as dispersion. But now the point is, when the lead shots start dispersing, will it travel for a longer distance or shorter distance? Yes, it will travel only for a shorter distance because it's already spread. Now the point is, you don't want it to go for a shorter distance. You want it to go for a longer distance. You want the range to be more. How will you increase the range? For increasing the range, what you can do is, you take the same smoothbore gun. Again, you take the same lead shots, but there is only one modification that you have to do. What is the modification that you have to do? What you have to do is, you need to constrict the last few centimeters of the barrel. Right? The last 5 to 7 centimeters of the barrel is constricted. You can say last terminal 5 to 7 centimeters of the barrel is narrowing. You are constricting the last few centimeters. 5 to 7 centimeters, that is not so important. Remember, we are constricting, that is important. So what we do is we basically constrict the last few centimeters of the barrel, and this phenomenon is called as choking. Do remember, this is called as choking. We are going to learn one more choking, but that choking happens in asphyxial death. So don't get confused with the choking of asphyxial death and the choking of firearm. So this is a choking which happens with the smoothbore firearm. Right here, when you do the narrowing, when you do choking the gun, what happens is, now what happens, the lead shots, the dispersion is reduced. You can see there is a reduction. There is a reduction in the dispersion of the lead pellets, so that you can have increased range of the lead shots, lead pellets. Fine. So do remember, I told you that we have rifling in a rifle gun, we have choking in a smoothbore gun. Don't worry about how many inches are restricted. See, we have lot of grades of choking. We have what is called as unchoked gun, right? We have quarter choked, half, 3/4, fully choked. Unchoked is also called a cylinder, right? Cylinder. You have lot of choking are there. You have a lot of grades on there. Don't worry about what exact measurement is there. That is not so important. You can see the point that you have to remember is you have different grades of choking. Now the point is, on one end you have unchoked gun, on another end you have got fully choked gun. You tell me which will have maximum dispersion, which will have least dispersion. Right, which will have maximum dispersion and which will have least dispersion. Do remember, unchoked gun will have maximum dispersion, one of your previous NEET MCQ, whereas fully choked gun will have least dispersion. Right, so this is very important concept, very simple concept. It's not so complex, man. Very, very simple concept. You take, suppose, have you ever watered a garden with a hose pipe? Yes, most of you must have, right? So when you want to increase the distance of watering, what will you do? In the hose pipe, you constrict the terminal part and the water, the range will increase. The same thing happens here. When you constrict the terminal part, the range will automatically increase. As simple as that. Right? I told you rifle gun, I told you smoothbore gun. Right? Rifle gun and a smoothbore gun. In rifle gun, we are using bullet. In a smoothbore gun, we are using lead shots. What is the purpose of rifling? Increase in stability. What is the purpose of choking? You want to reduce the dispersion of lead shots. Since we are using lead shots in a smoothbore gun, we call it a shotgun. Not only that, since you can see the dispersion pattern, it is also called as scatter gun. It is also called as pepper gun. You have lot of names. Right? What you need to know is the basics. What is the basic? It's a smoothbore gun, shotgun. That is sufficient. Right? I would like you to see this kind of rifling and a smoothbore gun. Here you can see the rifling, which is so typical, right from the inner end up to the outer end. It is so simple and it has got groovings. It has got groovings. How do you make this kind of groovings? You use what is called as broach cutter. Right, they will take an iron rod, I mean steel rod, using what is called as broach cutter. They groove it. They groove. So you have broach cutter, and not only broach cutter, you have lot of devices, lot of instruments to produce this kind of groovings. Right. So you have what is called as broach cutter, and you also have hook cutter. Lot of things are there, and all this cutter will produce specific type of groovings. Okay, so that will help us to identify the gun later. For now, you remember we have a lot of instruments to produce this kind of grooving or cutting. Fine. So this is rifling, and the other one, this is smoothbore gun. You can see it is completely smooth. Right? You can see it is completely smooth. And what is the purpose of this kind of grooving, rifling? You need the bullet to be spinning. Why do you want a bullet to be spinning? When it is going like this, it may not travel properly. It will be unstable. When it is spinning and going, it goes faster. It goes, the precision will increase. It is stable. It is stable. Now you see this is smoothbore gun. You can see this is smoothbore gun. Now look at the lead shots. This is unchoked gun. Do remember this unchoked gun. Look at the dispersion pattern. Completely dispersed. You see the range it covers is very less. Now this is choked gun. Now I am doing choking. I am constricting the terminal few centimeters of the gun. I am choking it. You can see that I have choked it. Now what happens? You see the same lead shots coming out, but the reduced dispersion. Dispersion is reduced. It can travel for a longer distance. Right? I have unchoked gun. I also have fully choked gun. You tell me which will have maximum dispersion. Yes, unchoked gun will have maximum dispersion and fully choked gun will have least dispersion. Very, very less. It can travel for a longer distance. The range is increased. You can see the various grades of choking. unchoked cylinder. You can see modified, full choke, improved cylinder, doesn't matter, just no choking, that is sufficient. Right? See, on one end you should have a rifle. On other hand, you should have a smoothbore. You have two important varieties of a firearm. I have given you everything in a single slide. Now, there is one more gun. There is one more gun which is basically a smoothbore gun. Let us say this is the barrel which is completely smooth. Right? You can see this is the barrel which is completely smooth. Right? But even though the barrel is completely smooth, the outer end of the barrel, the terminal few centimeters of the barrel will be having rifling pattern. Right? The terminal few centimeters of the barrel will be having rifling pattern. Remember, it's a mix of both. When it is a mix of both, you call this as paradox gun. Right? We call this as paradox gun. Either we can use lead shots or we can use lead slug. We'll be discussing of all these different types of lead shots. Doesn't matter. Just know paradox. Right? It's a paradox. Mix of both. You can see this is a mix of both. That is paradox gun. You can see the terminal, right? Rifling. Few centimeters are rifling. Now let's talk about the technical specification. See, if you refer a gun, firearm, let us say rifle. Right? You see, this happens to be the outer end of the gun. Right? This happens to be the outer end of the gun, muzzle end of the gun. The muzzle, you are looking at a gun, you take a gun, you see the outer end of the gun is there, you look at the gun, you are able to see something like this. Right? You can see some elevated parts are there, some depressed parts are there. You tell me what is this? Right? Is it a rifle or a smoothbore gun? Is it a rifle or smoothbore gun? You can see some elevated part and some depressed part. When you are able to see elevated part and depressed part, definitely it has to be rifle because these are nothing but riflings. Remember, the elevated part is termed as lance. Right? The depressed part is termed as groove. Elevated part is called land, the depressed part is called groove. What you have to do is, you need to measure the distance between two opposite land. You can see two opposite land. Not one and the neighbor, adjacent one, not like that. Two opposite land. You need to measure the diametrically opposite land. You can see diametrically opposite. Right? This is called as caliber. Do remember, this is called as caliber. This is called as caliber. Right? And we are using this word caliber in a case of rifled firearm. In a case of rifle firearm, right? So caliber is a word that we use for rifle. It can be expressed in terms of inch or it can be expressed in terms of millimeter, 12 mm, 15 mm, 9 mm, something like that. Okay, right? Now you see, this is a rifle. I have got another gun. I took the gun, this is such a long gun, big gun. I look at the barrel, the outer end of the barrel is completely smooth like this. You can see it is completely smooth like this. So when I see a gun like this, which is completely smooth, is it a rifle or a smoothbore gun? Yes, it has to be a smoothbore gun. But here we need to measure, we need to technically specify what is called as gauge. Right? We call this as gauge. It is also referred as bore, gauge or bore. Right? In a smoothbore gun, we have what is called as gauge or bore. Fine. Now you see here, I told you have a completely smooth surface, right? We have completely smooth surface. The point here is, when it is completely smooth, how will you measure? When it has got elevation depression, you could easily measure. This is caliber, right? You can see something like this. You can easily measure the distance between two land. It is called caliber. But now when it is a smoothbore gun which is completely smooth like this, how to measure the caliber? We have two important types are there, two important ways of measuring. Number one, either we can directly measure it. How do you measure? You take internal diameter directly. Measure the internal diameter directly. That is a direct method. There is another method, that is indirect method. Indirect method is something which is little more complex and that is expected in the examination. I'll tell you how to measure this gauge indirectly. Right? You can see here, I have given you, this is the smoothbore gun. I have given you a smoothbore gun. I have also given you lead. You can see the lead bar. How much of lead bar I have given you? I have given you 1 pound of lead. Right? What is 1 pound? 454 grams. Right? That's not MCQ. Right? General knowledge. Right? You can see 1 pound of lead I've given you. I'm giving you the task. What am I telling you? I am telling you that you need to make a lead ball. You need to make a lead ball of the same size of the barrel. If barrel is of this size, you are supposed to make a lead ball exactly of the same size that should precisely fit this barrel. Right? That should precisely fit this barrel. Suppose if the lead ball is of this size, how many balls of this size that you can make from 1 pound of lead? How many balls of this size that you can make from 1 pound of lead? If suppose you are able to make 18 balls of that size from 1 pound of lead, that is called 18 gauge. I am giving you another gun. You can take another smoothbore gun. This is even smaller. Again, I am telling you 1 pound of lead, make a lead ball of the same size of the barrel. But how many balls that you can make now? Now if you are able to make more number of balls, you can see you have made so many number of balls. You can see 1, 2, 3, 4, 5, 6, 7, 8. 8 into the 24 balls that you are able to make. If you are able to make 24 balls from 1 pound of lead, if you are able to make the ball of this size from 1 pound of lead, you are able to make 24 balls. That means it is 24 gauge. Right? That means basically it is the number of lead balls, it is the number of spherical lead balls, that should exactly fit the size of the barrel. Right? How many balls that you can make from 1 pound of lead? Number of spherical lead balls made from 1 pound of lead. What is the criteria? The criteria, the size of the ball should be the same size of the barrel. In case, if you have got two important guns, one is 18 gauge gun, another one is 22 gauge gun or 24 gauge gun, which has got bigger diameter, which has got lesser diameter, which is bigger, which is smaller. Yes, obviously, it is 18 gauge will be bigger than 24 gauge. That means as the number of gauge keeps on increasing, the diameter keeps on narrowing down. Diameter keeps on decreasing. Right? The more the number of gauge, the lesser the diameter it is. So this is basically gauge or the barrel. I told you there are two important methods of finding it out. One is direct measurement, another one is indirect measurement. What I have just explained to you is indirect measurement. Now, I have told you about the gun, I have told you about the ammunition. Now, let me tell you how this ammunition is loaded, how it is given to the firearm. You cannot just take one bullet and put it into it. You can't do like that. See, how does it work? I'll tell you how does it work. Let us say the ammunition. Right? This is the ammunition. How does it work? You have something called projectile. What is the projectile? I told you guys. What is a projectile? Projectile can be a bullet or it can also be a lead shots. Right? Lead pellets. For this projectile is going to come out for propelling this projectile. I repeat, for propelling this projectile, you need propellant. What is that propellant? Propellant is something which is going to push the projectile out. That is in simple words. It is going to push the projectile out. This is propellant, and this propellant is nothing but your gunpowder. Gunpowder is a propellant. Right? Gunpowder will blast and that is going to push the projectile out. But how will you burn the gunpowder? Just like that, gunpowder cannot spontaneously blast, right? For blasting the gunpowder, I repeat, for blasting the gunpowder, for blasting the propellant, you have what is called as primer. Right? You have what is called as primer. It is a primer mixture. We'll be learning about all the mixtures in it, composition of this primer. This primer, basically, it is impact sensitive or shock sensitive, right? It is sensitive to shock, pressure. So what you have to do is, you need to hit the primer. When you hit the primer, it burns. When it is burning, what happens? It is going to burn the propellant. It's going to blast the propellant and the energy is going to push the projectile out. This is the simplified version of the ammunition. But the type of ammunition, it varies depending on which gun that you use. Whether you use a rifle gun or you use a shotgun. Let's discuss about that. Let us start with, so this is the basic fundamental that you have to know. I have given you the basics fundamental of it. Now I'll tell you the structure of the ammunition that we are going to use. To start with, let us start a shotgun cartridge. Let us say this happens to be the shotgun cartridge, right? So this is the shotgun cartridge, which is usually made up of a cardboard, right? Fine. Now, but the last base, the base alone, alone is made up of a metal, right? Because so it has to withstand the pressure, right? So it has to made up of a metal. End alone is made up of metal. So this is the case. Shotgun cartridge. We call it as shotgun cartridge, right? We call it as shotgun cartridge. It has got three basic parts, right? Three basic compartments. You can see that the basal compartment has got what is called as gunpowder, the propellant, right? You can fill it with gunpowder. What is this? I repeat, it is gunpowder. It is gunpowder. In the same compartment, in the basal compartment itself, you have got one more important box, right? One more important cup. We call it as primer cup. What is this? This is called primer cup. This is called primer cup, which is also called as percussion cup, right? It is called percussion cup. It is also called as detonator cup. It is going to detonate. It is going to detonate the gunpowder. That's why it is called detonator cup. You have various names. Doesn't matter, right? So what do you need to know? It is called primer cup. So what should it contain, right? Applying your common sense, you can easily say that it should be containing what is called as primer, because it is a primer cup. It should contain primer mixture. It has got primer mixture, right? Now, this is the basal compartment, above which we have got a separation. Right? What is this separation? This separation is basically made up of a wood. It can be made up of felt. It can be made up of cork. It can be made up of plastic. It can be anything. Look, you can look at this separation, right? This separation is called as wad. Remember, it is called as wad. It can be made up of felt. It is made up of cork. It is made up of plastic. It can be any material that you can use. I'll be showing you the different types of wad. So imagine that this is like a separation. You're going to have a cork. On the top of that cork, you are going to place the lead shots. Right? These lead shots are the projectiles. And what you do, you just close the cartridge at the top. You can fold it. Right? This is basically a paper, wood, cardboard, right? So you can fold it inwards, so that when the projectile is coming at a high speed, this will automatically open and it is discharged, right? You can just fold it. Fine. So I've told you the three important compartments. The basal compartment has got gunpowder. On the top, you have got wad. On the top, you have got lead shots, right? Now the point is, as I told you, you need to start igniting the primer cup. Right? When you talk about primer cup, I told you the primer, it has got the primer. The primer is basically impact sensitive. Just now I told you it is shock sensitive or impact sensitive. What does it mean? If at all I hit at the primer cup, the primer cannot withstand the pressure. It will start burning into flame. Right? It will start burning into flame, but you can see a small hole at the top of the primer cup. Through the hole, the flame will escape into the gunpowder compartment. You can see the flame escape into the gunpowder compartment. The gunpowder will get blasted. When it is blasting, it produces a lot of energy that is going to push the wad. Wad is going to push the lead shots. You will be looking at the lead shots coming out. Right? The projectile has come out. As simple as that. You need to hit at the base. Now what will come and hit the base? Remember when I told you in the beginning, we have a trigger, we have the hammer, the firing pin. When you pull the trigger, the firing pin is going to come and hit this base. Right? So it is going to hit the primer. Primer will burn. It is going to burn the gunpowder. Gunpowder will get blasted and the lead shots going to come out. We are discussing the shotgun cartridge. Why do you need wad? Why do you need wad? In case, suppose if you don't have wad, imagine that you don't have wad in a shotgun cartridge. Lead shots are there, gunpowder is there, both will mix together. You cannot have complete blasting. So this is important for separation, right? It is separating. It separates the lead shots from the gunpowder. Not only that, you can add some grease on it, right? Normally what happens, there will be a disc will be there, right? you can add grease into the wad, so that suppose if this is the barrel, lead shots coming out, wad will also come out. As the wad comes out through the barrel, it is going to lubricate the barrel itself, right? So it is also useful for lubrication purpose. Lubrication, right? And whatever energy that is happening in the gunpowder, whatever energy that is released in the gunpowder, it cannot escape so easily out in between the lead shots, right? You have a wad, imagine you remove the wad, you have lead shots and gunpowder blasted. The energy, the gas that is produced, it can escape through the lead shots, in between the lead shots. It cannot have proper shotting. It cannot have proper firing. So what happens? You keep the wad so that the wad is acting, it is sealing the air pressure. It seals the air pressure so that it is directly given to the lead shots properly. We call this as obturation, right? We call this as obturation. Fine. And another one, again, you have the wad, on the top you have the lead shots. Here you burn the gunpowder. When the gunpowder getting blasted, this wad pushes the lead shots like a piston. Right? It is pushing the lead shots like a piston. You can remember separation, lubrication, obturation. It works like a piston. It has got so much of function. Don't think wad is nothing, wad is useless. It's not so. It has got so many important functions. Separation, lubrication, obturation. It works like a piston. But again, it is harmless. You know why? Because normally the wad, it can travel only up to 2 to 5 meters. It produces only minor contusion. It doesn't produce any fatal injury. It doesn't produce any fatal injury. Lead shots may produce fatal injury. WAD doesn't produce any fatal injury. We'll be discussing that later, no problem. For now, you remember what is the function of WAD. I've told you the primer, I told you gunpowder, WAD and the lead shots. You can see which is the most important part of the shotgun cartridge. They say the brain of the cartridge. Who's the brain of the cartridge? Right? The brain of the cartridge is the primer cup. Because only when you have primer getting fired, then you have gunpowder getting blasted and the lead shots will come out. So they say the brain of the cartridge is your primer cup. So I told you about the shotgun cartridge. Now we'll be discussing with rifled bullet. Right? You can see the rifle bullet. You can see the unit of the rifle bullet. You can see that it is made up of a bullet case. Remember, it is made up of a bullet case, which is usually made up of a metal, like a brass or something. Right? Again, inside the bullet case, what we do is we fill the bullet case with gunpowder. Fill it with gunpowder. Right? Remember, this is your gunpowder. As usual, you have got primer cup, right, which has got a small hole in the middle of the cup and which is containing nothing but primer. Let us say this is the primer. On the top of the gunpowder, you can directly keep the bullet. You can see this is the bullet which you can directly keep on the gunpowder. You don't need any kind of adding because this is one bullet, one single piece. You can directly keep it on the gunpowder. It is not going to spread. Right? You don't need any wad at all. You don't need any wad. You can directly, it's a one single piece, you can directly keep on the bullet. Doesn't matter. And the bullet case is there, right? The bullet case will be just constricted here. We call this as, see, this part is basically the bullet. You know what it is made up of, normally lead. And you have a small constriction of the case here. That is to hold the bullet. That's called cannulaire. Right? We call this as cannulaire. Cannulaire is a constriction. Right? It's called cannulaire. Doesn't matter. You have the gunpowder, you have the case, the primer cup and the bullet. As usual, what you are supposed to do, you need to hit at the base. When you hit at the base, the primer is so shock sensitive, impact sensitive, it cannot withstand the shock. It burns up. When it is burning up, the flame enters into gunpowder compartment. The gunpowder gets blasted and the bullet is going to come out. Remember, the first one I told you that is for shotgun cartridge. The second one that is going to be for rifle gun, that is bullet. Both are very, very similar. Except for the lead shots and the bullet. Right? Of course, the wad. You can see this shotgun cartridge. This is gunpowder. This is wad. You can see the lead shots. See the primer cup. Hit at the base. Right? Hit at the base. You will get everything coming out. You can see this is the bullet case. This is case. You can see the gunpowder, that is propellant. You can see the primer cup. On the top, you can see the bullet single piece directly kept on the bullet. Right? There is no wad. You don't need any wad. Fine. So do remember, this is about the ammunition, about the shotgun cartridge and the rifle bullet, right? Now we were discussing about the different structure of it. You can see that in the same slide that I've given you both. Now you can see we'll be discussing about what we use in everything. I told you gunpowder, I told you primer, you have so many things, right? So let's talk about the propellant. Let's talk about the propellant. What is that propellant? That is nothing but gunpowder. That is nothing but gunpowder. Let's discuss about the different types of gunpowder, right? You can see the first and foremost, the first gunpowder is black gunpowder. It is black gunpowder. Why it is called black gunpowder? Because it is looking black, that's why it is called black gunpowder. I'll tell you why it is looking black in color. Then the next type is called little advanced. Here we have what is called a smokeless gunpowder. Smokeless gunpowder, right? And we have the last one that is called semi-smokeless gunpowder. Basically, we've got 3 types of gunpowder being used. The black one is the oldest one, right? Olden days, that was the first gunpowder to be invented and people were using it. But the point is, if it is black gunpowder, it produces very less energy, right? You can see 1 gram, 1 gram can produce 3 liters to 4 liters of gas, that's all, not more than that. But it produces lot of smoke. Whereas you compare with smokeless gunpowder, 1 gram can produce 12 liters to 13 liters of gas, and you can see it produces very less smoke, and obviously that's why it is called a smokeless. Right? Now you see what are the components of black gunpowder. If you talk about black gunpowder, do remember it has got 3 important parts. Number 1, it has got potassium nitrate. Remember, it is not potassium chlorate, it is potassium nitrate. Potassium chlorate is a part of your primer. So this is potassium nitrate, right? And we have got charcoal. That is the reason why it is looking black in color, and it has also got what is called as sulfur. You can see potassium nitrate, charcoal and sulfur. You can see potassium nitrate will be around 75%, right? Charcoal will be 10% and the sulfur will be, charcoal will be 15% and the sulfur will be 10%, right? How can you remember? You can remember like this. You can remember Preeti can sing, right? Potassium nitrate, charcoal and sulfur. If you want to replace Preeti with some other name, you can change Prabhu, right? You can see any name. You can, whatever name that you like, you can change it. It should start with P. That's it. Okay. Preeti can sing. Remember potassium nitrate, charcoal and sulfur, right? Potassium nitrate, the topmost, 75%. Then comes charcoal, 15%. Last one is sulfur, that is only 10%. Smokeless gunpowder. Let's talk about smokeless gunpowder. It has got 3 bases. What are the 3 bases? See, it has got nitrocellulose, nitroglycerin, GLY, glycerin, right? And nitroguanidine, GU, guanidine. You can see that I have arranged it alphabetical wise. Cellulose, C first. Then we have got glycerin, GL. Last one is GU, that is last one. We have got 3 bases. It is up to you to use how many number of base that you want. If you are using only 1 base, that is called single base gunpowder, right? Wherein it will have only nitrocellulose. You can use 2, that is double base gunpowder. You can use 2 bases together, right? You can use a combination of nitrocellulose plus nitroglycerin. Nitrocellulose plus nitroglycerin. You can use all the 3 together, triple base. Single, double, triple, right? You can use single base, you can use double base, you can also use triple base. It is nitrocellulose, nitroglycerin plus nitroguanidine. All the 3 together, it is called as triple base. As simple as that. 1 is single base, 2 is double base, all the 3 together, that is triple base. Very simple. Semi-smokeless gunpowder, right? We have got semi-smokeless gunpowder. It's a combination of both. You have what is called as black gunpowder, right? You have a combination of black gunpowder plus smokeless gunpowder together, that is called semi-smokeless gunpowder. This is 80% black gunpowder with 20% smokeless gunpowder. You call it as semi-smokeless gunpowder. Fine. So this is about the black, the smokeless and semi-smokeless. We were discussing about the propellant that we use. But black gunpowder, again, you can see that you can designate that as FG. You can see FFG. F, 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 G, F, 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 G. You can keep on increasing the number of F. What does F refers to? Do remember, the F refers to fineness of the gunpowder. G refers to granules, right? It refers to the granules, fineness of the granule. The more the number of F here that you have got, the fineness will keeps on increasing. Fineness will keep on increasing. Right? FFFFG, that means it is more finer, just like your talcum powder, right? Talcum. When it is only FG, it is coarse, like beach sand, right? You can see it is the more number of F is that you have got, more the number of F you have got, that more finer the powder it is, the more finer the granule it is, right? That's what you have to remember. I can just show you the different types of gunpowder. You can see this is black, smokeless, and you've got mixture. You can see this is FG, FFG, this is FG, FFG, FFFG. It keeps on increasing, right? This is more finer. This is more finer. Now, when you want to burn the gunpowder, what do you need? You need what is called as primer. What is the purpose of primer? The primer purpose is to blast the gunpowder. Remember the word blast. It is going to blast the gunpowder. That is what I'm giving you as a mnemonic. You can see BLAST, B for barium nitrate, L for lead peroxide, A for antimony sulfide, S for stiffnate, lead stiffnate, and T for tetrazine. Right? So you've got barium nitrate, lead peroxide, antimony, lead stiffnate, and the last one is tetrazine. These are all the composition that we use in primer. They can ask you which of the following is not a primer. They can give you nitroguanidine, lead stiffnate, lead peroxide, barium, right? You need to say nitrocellulose is a component of your gunpowder, not the primer, right? Whatever it is, fine. So you need to know what belongs to gunpowder section and what belongs to propellant, that is primer section, right? Primer is different and gunpowder is different. Which is so impact sensitive? Primer is impact sensitive. Now I've told you, you can see that I have told you about the primer, I've done it, right? I have told you about the gunpowder as well. I need to tell you about the projectile. What are the projectile that we use? We use bullet as a projectile. We also use lead shots as a projectile. We are going to discuss about that. So let's talk about lead shots first. Let's talk about lead shots. As the name implies, it is made up of lead normally. When it is made purely of lead, you call it as soft shot. Pure lead, right? But the point is that pure lead is very soft. It can deform. So you want to harden it, you add some metal into it, right? Like antimony or something, that is called hard shot or chilled shot. Chilled shot, right? You're not chilling it. It is adding metal into it. Adding metal into it, that becomes harder. You call it as hot shot. Then the last one is your steel shot, wherein you have only pure stainless steel. You have steel that is used to make a shot, right? So that's what I told you in the beginning itself. Usually the lead shots are made up of lead, but sometimes the shots are not only made up of lead, you have other components as well, right? So we have soft, that's pure lead. Then we have hard shot, some metal is added. And the last one is steel shot, fully completely made up of steel. Now the point is, depending on the size that you can classify, this is the type of shot. The first one is dust shot, wherein you can have up to 2000. It is so smaller, it will cover a bigger range. Next one is bird shot. You want to cover a larger range so the birds will fly, right? You need to have a larger range so that it will eat the bird, right? So here you will be getting around 200. Around 200 shots can be there, right? Then little larger one, that is called buckshot. You're going to hit the buck, right? It should be larger. So it will be having around 20. 9 to 20, something like that. And the last one is rifle slug. This is a single large piece of lead. Single large piece of lead, that is called rifle slug. You can see this is your bird shot, this is your buckshot, and this is your rifle slug. Fine. So you have various types of that depending on the size of the lead shots, right? Fine. Now let's talk about. Hi guys, now we have discussed about the different type of lead shot. Now we'll be discussing about the different types of bullet that we have got. What are the different types of bullet that we have got? Do remember, when we talk about bullet, the energy that is given by the bullet, the damage that is given by the bullet, it is not only dependent on the mass of the bullet. We know that is half mv squared. So it is dependent on the velocity that is coming out. If you are just throwing the bullet like this, it may not cause injury. But when you are throwing at a high speed, it will cause injury. So the velocity is more important than the mass of the bullet. Let's look at the different type of bullet. I told you earlier, the bullet is made up of lead. You can see this is lead. right? Only lead core is there, nothing else is there. This is non-jacketed bullet, right? So this happens to be non-jacketed bullet, wherein there is no covering. The lead alone is there, lead core alone is there. It can easily deform. But sometimes what happens when you use this kind of non-jacketed bullet in the barrel, right, in the gun, it may get, because of the heat that is produced during firing. Because of the heat that is produced during firing, these lead can get molten. It can melt. It can stuck to the inner surface of the barrel, right? It will cause damage to the barrel. That is the reason why they started having coating out, right? They started coating it out. They have some jacket, right? We have a metal jacket. The metal jacket can be made up of, the jacket can be made up of a copper or nickel. We can say any metal which is coating. The central core is lead only. We are covering it on all sides by a metal jacket. This is called fully jacketed bullet because it is covered on all sides by a jacket. This is fully jacketed bullet. But sometimes, see, fully jacketed will have maximum penetration. But now the point is, sometimes you don't want to have maximum penetration. You have special types of bullet. In the first bullet, you can see that the jacket is not covering completely the bullet. It is covering only up to the half. You can see it is covering only up to the half of the bullet. This is called semi-jacketed bullet. This is called as semi-jacketed bullet, right? Which is also called as dum bullet. What is the dum bullet? This was originally prepared by British Army in Dum area, Kolkata, right? In Kolkata, there is Dum area where this kind of bullets was specifically manufactured over that area. That's why it is called as dum bullet. But what is the advantage of this bullet, or you can say what is the effect of the bullet? These bullet will deform on impact. So what is the speciality of this bullet? What is the uniqueness of this bullet? These bullet on impact, it will deform. It deforms on impacts, right? We can also call it as mushrooming, right? It will expand. It's called as mushrooming. You can see that the another type of bullet, this is called hollow point bullet. You can see it is also semi-jacketed, but you look at the tip, it is hollow, right? It is hollow. It is hollow point bullet. Again, this kind of bullet as well, this bullet also will deform on impacts, right? So both these bullets will deform on impacts, right? So it will cause mushrooming. Remember, it will cause deformation, right? Fine. Now there is another type of bullet. You can see this is another type of bullet. This is not made up of lead. This is made up of powdered iron or powdered copper, right? You can say this is made up of powdered iron, right? But when you have this powdered iron instead of lead, what happens? On impact, it gets broken. It gets disintegrated into multiple pieces. When it is disintegrated into multiple pieces, we call this as frangible bullet, right? This is called as frangible bullet. The bullet that gets fragmented on impact, right? It gets fragmented on impact. It gets disintegrated on impact, right? So this is called frangible bullet, disintegration on impact. Right now, see, this bullet is manufactured specifically that it should get fragmented on impact so that you will have limited penetration, right? You will have limited penetration. This is specifically prepared for limited penetration. This is called frangible bullet, also called as, this bullet is called frangible bullet, also called as fragmented bullet, right? Sometimes what happens, if this bullet is entering into the tissue, it can cause multiple fragments. It can cause what is called as lead snowstorm. We'll be discussing that later, right? Lead snowstorm. You can see multiple small pellet particles inside the tissues. Lead snowstorm. This is not only seen with frangible bullet, it can also be seen with dum bullet as well. So now I've told you what is called as frangible bullet, also called as fragmented bullet. Now we have other types of bullet as well. Let us say if this is the bullet, right? This is the bullet. The base of the bullet will be having some chemicals, right? These chemicals will glow, right? On firing, this will glow in the air. On impact, on firing, you pull the trigger, bullet comes out. These kind of bullet, they'll glow so that you can trace the path of bullet. You can trace the path of bullet. When you can trace the path of bullet, do remember this is called tracer bullet. right? This is called as tracer bullet. You can trace from which direction it is coming from, right? You can find out you can trace the direction, you can find out the direction of the bullet. That's why it is called tracer bullet. There is one more type of bullet wherein you can see that this is the bullet. You can see that this is the bullet, right? On the tip of the bullet, they will have some phosphorus-like inflammatory material. What happens on impact? It will catch fire. So you can say phosphorus. You know very well phosphorus is inflammable. On impact, it will catch fire. Fire on impact. We call this type of bullet as incendiary bullet. What is that? It is called incendiary bullet. Incendiary bullet. Fine. So we have got incendiary bullet. All these bullets are there. What is explosive bullet? Explosive bullet is something that explodes on impact. Explodes. Right? Explodes on impact. Plastic bullet, you know, that is made up of PVC, which is normally used by police for controlling the riots, right? And you know, poison bullet. Poison bullet is this kind of bullet will be having some chamber inside. They will have some resin or curarin. What happens is that will have a small hole will be there at the tip of the bullet. This poison will be slowly delivered into the tissue of the victim. Slowly, the poison will be delivered into the tissues of the victim. So that is called poison bullet. Very rare, right? You can see these are all the different types of wad that we have got. I told you we have wads, right? Wad is maybe made up of cork, maybe made up of felt, or it may be made up of plastic. It can be anything, right? So all these are the different types of wads that we have got, right? There is one more type of cartridge that is called tandem cartridge. It is also called as duplex cartridge. What is that? Tandem cartridge, also called as duplex cartridge. Duplex. What is it basically? You can see that this is the bullet case. We know what is the structure of the bullet, right? So this is the bullet case. Normally you will have one bullet. But in this case, what happens is you will have two bullets back to back kept. Right? When you have two bullets in the same cartridge, that is called tandem cartridge because it is back to back, one behind the other. That's called tandem cartridge, also called as duplex cartridge. We were discussing about the proximal ballistics so far, right? What is the sequence of firing event? Whenever you pull the trigger, hammer goes up, firing pin moves forward. Where does it hit? It is at the base of the primer cup, right? The primer burns, it is impact sensitive. The fire enters into gunpowder compartment, gunpowder explodes, and the bullet or lead shots, they come out, right? So this is how it works. This is the sequence of the firing event.